All right, we're looking at a sample AP question from a practice book. We are going to find our function f of x, 2x to the fourth minus 4x squared plus 1. And we've kind of got, typically in AP problems, we've got like an A, B, and a C, sometimes a D. Always looking to justify. So we're kind of going to go through this piece by piece. Find an equation of the line tangent to the graph at -2, 17. So to find the equation of a line tangent, we want to find the derivative to find the slope of the tangent. So the derivative of function f is going to be, using the power rule, 8x cubed minus 8x. And then if I want to find the derivative at 2, f prime of -2 is going to be, looks like -64 plus 16. So my slope is actually going to be -48. And that's my slope. And I've got my point. So for A, y equals -48, x minus -2 plus 17. That would be enough of an equation of a tangent line. Great. Now let's find the x and y coordinates of the relative maxima and minima. Verify your answer. So I am going to keep our derivative, and I am going to delete our other work here. Let's take a look. If we set our derivative equal to 0, that's how we find our extremas. So if I factor out the 8x, I get x squared minus 1 inside. So x equals 0 and x equals 1, x equals -1. So I've got 3 zeros. Now we need to decide if they are relative maxima or minima. And my first idea would be, this is a no calculator one, but can we sketch the graph from Algebra 2 of just a total approximate graph of something to the fourth power? And it's positive, so it's got to be something like that. We don't know, we don't need to know exactly, but using that as a rough sketch, we should know that we're going to have 2 minimums and a maximum. So now our justification needs to be a couple options. We could find the second derivative. That is 24x squared minus 8 set. And then we could actually find the values of the second derivative in these and talk about its concavity. So let's try that first. That's good justification. So f double prime of 0 is -8. F double prime of 1 is 16. And f double prime of -1 is also 16. So what we'd say is, at 0, it must be a maximum because it's concave down. Max because concave down, meaning the second derivative is negative. Similarly, here at 1 and -1, those must be minimums because the second derivative is positive, meaning it's concave up. Now, my writing here isn't complete, but the words I use need to be expressed in order to show enough justification. All right, then let's look at part C. Find the x, oh, I guess this one, okay, sorry. To finish B, find the x and y coordinates. So 0, when I put a 0 in, 0, 1 was our max. 1 comma, and I'm putting these into the original function. -1 was a min, and -1 comma -1 was also a min. So that was like my complete solution for B. And then in C, we will set the second derivative equal to 0 and subtract the 8, divide by the 24. X squared equals 1/3. So x equals plus or minus square root of 3/3. So those could be our points of inflection. Now, to verify or justify, what I would like to see, and remember our graph looked like this. So we probably have, those are probably the points we're looking at because we're concave up there, concave down there, concave up there. So here's what I'd like to see. I'd like to see a number line. And I'd like to see us put in negative square root of 1/3, positive square root of 1/3, and then talking about f double prime of x. So something below this, so let's go like, if I put something like negative 10 in, and I test a point in the second derivative. If I put negative 10 here and square it, times 24 minus 8, that's going to be a very positive number. When I put a number in like 0, I'm going to get 0 minus 8, which is a very negative number. And again, if I put in a number like 10, I'm going to get a positive number. So this number line shows that my second derivative is positive from negative infinity till negative square root of 1/3. So we're concave up. And then we're concave down. So we've shown that the concavity changes. If the concavity changes, we have a point of inflection. So to verify or justify, we had to show that it changed from concave up to concave down. Not bad, definitely all skills we have. Practicing that verifying and cleaning everything up would be ideal.